Hey everyone, let's look at two quick ones here in section 4.5, numbers 5 and 6. We're going to evaluate the limit using L'Hopital's rule. Number 5, this is our first limit. Notice we're taking the limit as x goes to infinity, and we dealt with these limits before in the previous chapter, if you remember, and we were able to evaluate these limits. You probably remember what that limit is pretty quick. But L'Hopital's rule is helpful. Notice as x goes to infinity, the numerator of this expression, 9x plus 4, is going to infinity, right? 9x plus 4 is just a line of slope 9, right? So it's just going up, up, up. The bottom function, 3 minus 10x, this is a line with a slope of negative 10, so it's actually going to minus infinity. But remember this form, infinity over infinity, it doesn't matter if they're plus or minus, right? This is an indeterminate form, and it is a L'Hopital form, as I say, right? This means limits of this form, infinity, infinity, infinity over infinity, or 0 over 0, right? We'll often be able to use the L'Hopital's rule, which is basically this, right? The limit as x goes to infinity of f of x over g of x when we have this form, or 0 over 0 is equal to the limit of the ratio of the respective functions' derivatives, provided this limit exists. And so pretty easy with this one then, because we have the form. I'll use L'Hopital's rule. And remember, when I do that, I would like you to do this too on the test. Over the equal sign, put an L to indicate you're using L'Hopital's rule here. Notice I have the limit still. I take the derivative of the top function. What's the derivative of 9x plus 4? Piece of cake, it's 9. What's the derivative of 3 minus 10x? Well, derivative of 3 is 0. Derivative of negative 10x is negative 10. So 0 minus 10, I get negative 10. And so what's the limit as x goes to infinity of a constant? What's just that constant, right? It's just staying the same at what 9 divided by negative 10 is negative 9/10. And that's the limit. That's all there is to it. So we did these limits way back in the chapter 2, but now here, coming back after learning the derivatives, we're able to use L'Hopital's rule and find these limits real easy. Let's look at number 6 real quick. Very similar. I have the limit as x goes to infinity of x over e to the x. Both of these functions are increasing on their domain. As x goes to infinity, they are both going to infinity. So this is infinity over infinity. So you do need to know the end behavior essentially, right? Limits at infinity for basic functions like e to the x, linear functions, polynomial functions, etc. So it's of the L'Hopital rule form. So I'll use L'Hopital's rule. What's the derivative of x? That's 1. What's the derivative of e to the x? Well, that's just e to the x. Well, what's happening now as x goes to infinity, the top is staying at 1, e to the x still going to infinity. 1 divided by infinity, that's not an indeterminate form, right? That is going to go to 0, right? 1 divided by a larger and larger value is approaching 0. So the limit is 0. So these are both really quick and easy, but really appreciate how L'Hopital's rule is helping us out with these limits. Hope this is helpful.